In this lecture, let's understand about the build process. So when you hit the build option in your IDE, your project will be built, right? So the building process actually involves a couple of stages. Your source file, what you have written, actually first undergoes pre-processing. And after that, your source code will be parsed. And then object files will be generated. And linking of all those object files will happen. And finally, an executable will be generated for your project. And optionally, you can do post-processing of the final executable. Let's understand all these steps. So broadly, the build process can be divided into two stages. One is compilation stage and another one is linking stage. So your source code, that is .c files, will be first pre-processed using preprocessor engine of the compiler, and the pre-processing stage produces .i for every .c file. So this is a stage where the hash include files will be resolved and all the C macros will be resolved and a .i file will be created. The next stage of the compilation or the compiler is parsing. So the parser engine of the compiler will then parse the .i files in order to check the syntax of the statements you have written in the source file. So syntaxes will be checked against the standard which you are selected, and if there is any error, if there is any problem with the code, it will be reported to the programmer at this stage. So if everything is fine, then the code is then converted into .s file using another engine of the compiler called code generator. So that means .i, later it will be converted into .s. So here is a place where higher level language such as C is converted into lower level language such as assembly language. That means for every C statement you have written, the equivalent mnemonics will be created in the .s file by the code generator. And after that, the assembler engine of the compiler converts mnemonics into machine codes. So at the end of the day, machines understand numbers, isn't it? So machine wants numbers, right? So your higher level language is converted into mnemonics. And after that, those mnemonics, later it will be converted into machine codes by the assembler. So assembler actually generates .o files, so which are also called as relocatable object files. So for every .c file, a .o file will be created by the assembler. So .o file is nothing but collection of machine codes of your .c file. And after that, linking stage of the build will be invoked. In the linking stage, so multiple relocatable object files will be combined into one executable file. So if you have, let's say, 5.c files, then 5.o files will be created. So each .o file will be having its own machine code, right? So the linker will merge all those machine codes into one file, and then it creates a final executable file. So in our case, the format of the final executable file will be .elf, where ELF stands for executable and link format. So basically, the GCC-based compilers will actually generate executable file of .elf. So it's a debug plus executable file. And after that, you can do post-processing on that ELF file using tools such as Object Copy and other tools to produce various other files like .bin, .hex, etc. So that's what we call as post-processing. So these are the steps involved in producing the executable file from the source file. So all these things happen at the background when you trigger the build. So now let's get into our project. So here I have a project called add and I have a main.c here. So here it is a very simple program where I have two global variables and I'm just adding those global variables. And after that, I'm storing the result into the third global variable, that is result. And after that, I'm printing that. So now let's compile this. So let me just clean the project first. And after that, let me build the project. So when you build the project, so here you can see that the compiler is invoked. So that compiler itself takes care of all the stages, like it does pre-processing, parsing, assembling, it does linking. So everything is taken care by this executable. So that is actually our cross compiler. So here you can see that first it actually compiles the startup file. So then it compiles the main.c. Then it compiles syscalls.c. Once the compilation and linking stage ends, the ELF file is generated, that is final executable. And after that, on that ELF, post-processing tools can be invoked, such as object dump or size, in order to gather more information about the executable which is generated. Like, for example, when you invoke this command, size, it actually gives the size of the executable, like the size of the code section, the size of the data section, the size of BSS section, etc. So if you want to see all these intermediate files such as .i, .s, and .o, then you can go to the build folder of your project, so where all these files are stored. Let's check that. So for that, what you have to do is you have to right click on the project and then select properties and go to the resource, and after that click this icon here. So this will take you to the folder where this project is placed, and the project folder will be opened. So here let's open this and go to debug. Here you can see that you actually by default don't find .i and .s files because those are actually not generated for the user. So those are generated internally and compiler uses them internally. So you have to instruct the compiler to create them and store in the file system. So we can instruct the compiler. So for that, what you have to do is you have to go to the properties here and go to the settings. And in the settings, go to the compiler settings, go to the miscellaneous, and here click on plus and type save temps and click OK, apply, apply and close, and then rebuild the project. So when you rebuild the project, so you can see that this folder is now populated with .i, .s, and various other files, right? So for every source file, there will be .i, .s, syscalls I, syscalls s, like that. And you already know what is main.i, right? So this is actually pre-processed source file. And if you open main.s, so this is nothing but mnemonics. Sorry about that. So let me open once again. So this is nothing but mnemonics, right? Mnemonics means it is actually an instruction which are generated for every C statement what you have written. So these mnemonics are from ARM Cortex instruction set architecture. If you want to understand about these mnemonics, then you have to refer to the instruction set document of ARM Cortex processor. And after that, .o file you can find in the source folder. So these are the .o files created for every .c file. So .o file is actually, it is machine code, right? So these are the machine codes. So you will not be able to read that. So the summary of build process. So the build process we can broadly classify into 3 stages: pre-processing, compilation, and linking. So with that note, I would like to end this video, and let me know if you have any questions, and I'll see you in the next lecture.